is the 2022 AMC 10A, problem number 23. Isosceles trapezoid ABCD has parallel sides AD and BC, with BC less than AD and AB equal to CD. There is a point P on the plane such that PA equals 1, PB equals 2, PC equals 3, and PD equals 4. What is BC divided by AD? Okay. So let's draw a diagram. All right. So we have an isosceles trapezoid, and we have these 4 lines that connect to P, right? So what is important about this problem is that is an isosceles trapezoid. So it's the fact that AB equals CD, and the fact that BC is parallel to AD. That's the thing about an isosceles trapezoid. So it might help to try and draw the parallel line through P. So we draw this parallel line through P, right? And this gives us a like BP as a distance 2 and C as a distance of 3 from the line, right? And we get distances of 1 and 4, right? So we can potentially get the idea of drawing another point P, like we want to draw another point on this line that could give us some more lengths to work with that could potentially help, right? So what other point could we draw on this line that gives us a lot of lengths? Well, the answer is the point opposite P, right? On this line, the point. We'll call this point P prime. And this is a point that is reflected across, we could say, the perpendicular bisector of this trapezoid. And from this point P prime, we get the exact same lengths, except on the other side. And if you notice, right, drawing this in makes a lot of mess, but this is also 3, and this is also 4, right? Which tells us that actually, because we looked at parallel lines, and the fact that these diagonals are equal and the sides are equal, right? That means that actually BC, P prime P is an isosceles trapezoid, and P prime DA is an isosceles trapezoid. And that is very important because if, say, we label these bases A and B, and maybe this segment in the middle C, we can actually use this theorem that is derived from isosceles trapezoids which is basically if we have an isosceles trapezoid with, let's just say, right? So given an arbitrary trapezoid of this form, what we can do is we can draw this altitude in the isosceles trapezoid. Like we could do this to each of these isosceles trapezoids, but that would be a bit messy because there's a lot going on in this figure. So let's just try doing it like this. Well, we know that if we drew in this line, right, it would make a rectangle, and this would be X. And then in order to make everything add up to Y on the other side, both of these would have to be Y minus X over 2. Right? Well then, basically what that means is that when we add the X back onto here, we get Y plus X over 2 as this side. And basically now we can express this altitude in 2 different ways using the Pythagorean theorem. This altitude squared is equal to z squared minus y plus x over 2 squared, and it's equal to w squared minus y minus x over 2 squared. And if we move stuff around, using difference of two squares here, we get y plus x over 2 minus y minus x over 2, which is just x, times y plus x over 2 plus y minus x over 2, which is just y. So w squared plus xy is equal to z squared. And we can use that in this figure here. If we use it on this on our isosceles trapezoid BC prime P, what we get is that 4 plus AC is equal to 9. And if we use it on trapezoid P prime D A, we just end up with 1 plus BC is equal to 16. So from here, AC is equal to 5. And from here, BC is equal to 15. And now what is the question asking for? It's asking for BC over 80, A divided by B. But we have AC and we have BC. So A over B is just AC over BC, which is just equal to 1/3.